and
Okay.
if there is no voltage, it is a 0. If plus 5 voltage, it is a 1. Like that, it will identify. Okay. See,
Okay.
for example, the receiver receive, this is the data it is received. So how decoding it happens? See, in protocol messages, you need to concentrate totally on the receiver side. How receiver will decode the messages? First, it will decode that. First, it will read the Ethernet header. Okay, it will remove the Ethernet header. Means it is a physical layer. For example, physical layer we are using Ethernet. It will remove the Ethernet header. Like that, it is go for next layer. Next is the IP layer. Then it will remove the IP header from here to here. Okay, for example, then it will read the TCP header, then it will remove the TCP header, then it will read the data, then it will remove the presentation layer header. For example, SSLv3 you are using, it will remove that. See, this is the data it is receiving. For example, this is the data it is receiving. How it is uh, the receiver, see, focus on receiver, not on the sender. In receiver, how it is receive the data, this is the data. Okay, this is the data. First it will read the physical layer, what is the frame number and what is the bytes, how many bytes. Then it will remove the physical layer header. Okay, then it will remove the layer 2, this is the layer 2 Ethernet. Then it will remove the IP header, this is the IP header, 20 bytes header it is. See, if I highlight IP here below, it will show you how many bytes. Then it will remove the UDP header, UDP is the 8 bytes. See, every protocol, in protocol side, it is a very important. You are getting right. Every layer will add the header from the sending side. Receiving side, it is removing the header and
Okay.
posting the data. For example, receiver receives a huge data, while removing the total headers, the original data is a very small. See, why these headers are useful is every layer we have a unique functionalities. For example, in data link layer, it is having source MAC address and destination MAC address. To transmit the data from one node to the another node, one system to the another system, this MAC address is the unique one, right? Like that, IP layer will
Yes.
having the IP addresses. So each layer will have its own functionalities. So to make a one simple header by combining all these, it is a difficult. That's why they divided different layers, and each layer have a unique functionalities. These 7 layers are not necessary. For example, if it is not secure connection, we don't need a presentation layer. Presentation layer will need only secure connection. Like that, these 7 layers are not necessary. uh, but uh, but every layer will add the own header. See, for example, this message, see here, presentation layer is not there directly. This is the transport to directly, this is the DNS, isn't it? For example, any HTTP data is there, you need a presentation layer. Here you see we are capturing some data. So this is the data capturing. Okay, every day, what I'm going to say is 7 layers are not necessary. You know that data link layer, right?
Okay.
So we are directly going for IP layer. What is the advantage of IP layer? IP layer will main responsibility. See, to communicate one system to another system, we need a IP layer. I mean, within the system, this MAC address is enough. But you want to communicate with far away system or different systems, this IP address is necessary. It will transmit the IP packets. These are called datagrams. These IP packets is called datagrams. Within the system, within the LAN cable, you can transmit one system to the other system by using the MAC address. But other systems you need this. And we have to, one thing here is, every system having a NIC card, isn't it? That is associated with IP address. There is a two types of IP address are there: static IP address and dynamic IP address. If you assign the IP address, I mean, you manually give the one IP address, it won't change. That is a static IP address. This dynamic IP address, It will every time it will give you the new IP address by using DHCP. Okay, DHCP will give the one IP address. This is the,
Okay.
yeah, IP address having addressing. See, there are two types of IP address are there: IPv4 and IPv6. See, this is a 32-bit. IPv4 is a 32-bit, and IPv6 is 128-bit. See, every IP address, you know IP address, right? So, see, the IP layer will perform the fragmentation. Fragmentation means it is dividing the data, small packets data. I will tell you what is the fragmentation. See, for example, the see, for example, this is the one router, and this is the another router. This is the third router. This is the router. Okay. See, from this router to this router, we are using the physical layer technology as the Ethernet. Okay. From this router to this router, we are using the PPP, point-to-point protocol. Okay. From this router to this router, we are using the, optical fiber. See, the physical layer is changing from layer to layer. Uh, See, if the router having four interfaces, the four IPs it is having router. That is called WIN card, WAN interface card. Every interfaces it is having one IP address. For example, the traffic enter from one interfaces through one IP, and it will go to another interfaces to another IP. This interface having one different IP. This interface is having one IP. Okay, so it is having different MAC address also, not only one MAC. For example, system having only one MAC address, right? The router having different NIC cards. Okay, here you can see that the physical layer is changing from node to node. It is not necessary to use the same Ethernet layer from every node. So if the physical layer is changing, the characteristics of the physical layer is changing. For example, Ethernet can pump the data up to 1500 bytes at one time, one packet. But PPP only transmit the data in 250 bytes. Optical fiber can transmit the huge amount of data based on the optical fiber. It can transmit 1 GB data also, speed. Okay, there are different kinds of physical technologies are there. So how the IP packet is transmitted? So they are dividing the IP packet. Here, for example, here 1500 bytes of IP data came. The physical layer is not supporting 1500 bytes, so it will divide the data into five packets. One packet is divided into five fragments. So we are calling it as a fragment and transmit it. The receiver side, it will combine all five packets and it will transmit here. You understand me, right? Here, simple thing is the physical layer is changing. Means it's not necessary to use the Ethernet in every link. So there may be different physical layers are present. The different physical layers are Ethernet is a one kind of physical layer, and the PPP is a point-to-point protocol is a one kind of physical layer characteristics, and frame relay is the one kind of, and optical fiber and coaxial cable, and copper wires. There are different kinds of physical layers are there. Physical layer means physical transmission. It will transmit the data into zeros and ones. That is a that physical wire. The wire we are using to transmit the data is called a physical wire. So that MTU, that maximum transmission unit changes. Optical fiber having the highest maximum transmission unit. Then Ethernet having the 1500. It is the MTU size of Ethernet. So if the physical layer is changing, the IP packet need to be stopped. For example, the 1500 bytes of IP packet came here, but Ethernet is not supporting this packet to transmit to another end. The physical wire is not supporting. So this router will perform the fragmentation. Fragmentation means divide this big packet into four small packets. Okay, one, two, three, four, and transmit here by numbering that this is the first packet, this is the second packet, this is the third packet, this is the fourth packet. And at receiving side, it will combining the all four packets, and it is going to transmit here. So the receiver will combine these four packets. See, you can understand one disadvantage here. There are not only four routers. There are, for example, 100 routers are there from your system to the Google server. From your system, this is the your system, and this is the Google server. Okay, there are lot of routers are there. Based on the physical layer, it is every it is dividing and combining the data, right? Based on the physical layer. If the physical layer characteristics are not changing, uh, it won't divide the data. If the, for example, physical layer characteristics are changing, it is dividing the data. So while dividing and combining the data, it is consuming the time, right? So every router will, based on the physical layer, if the physical layer is the same, it's no need to divide the data. For example, if the physical layer is changing, it is going to divide the data, isn't it? So it is a consuming the time. But in IPv6 case, it won't divide the data if physical layer changes also. How it is possible is, it will calculate the PMTU size, path maximum transmission unit. Okay. So before transmitting the data, it will calculate the what is the lowest physical layer size. For example, PPP is there. The size is only 256 bytes. So it will divide the data at the source side only and send it. So the advantage is the fast transmission is possible from one end to the another end. See, in IPv6 case, how it is perform is, it will calculate the PMTU, path maximum transmission. I mean, what is the maximum transmission unit of that this total path? See, this Ethernet is supporting 1500, and but PPP is supporting only 250. So the source itself it divide the data based on the 250. I mean, lowest fragment and transmit from one end to another. So in between the nodes, no need to divide the data. That case, we can avoid the dividing the data at the router in IPv6. But in IPv4, the router will perform the fragmentation based on the below layer, means data link layer. Are you understand, Indrish? You got the point? Hello, Indrish. Hello, are you understanding? Hello, Indrish. Hello, hello, Indrish. Are you there? Okay. See, it every time it is dividing the data. See, the internet modules use fields in the internet headers to fragment and reassemble the internet datagrams when necessary for transmission through smaller packets. Smaller packet networks means if the physical layer is changing, it is going to divide the data. That is called, that is the IP will perform. See, this is IP header. See, remember this is IP header. It is having version, IP header, type of service, total length, identification flags and fragmentation offset, time to leave protocol and header checksum, source address, destination address. This is the 20 bytes header is the fixed header, and it will change up to 40 bytes. Okay, these 20 bytes, this is up to here. These 20 bytes is the fixed header. So fixed header means at any cost, the IP header size is the 20 bytes. That is called the fixed header. Okay. Hello. Hello. Hello, Indrish.
Hello,
Hello. Are you understanding?
this is Satya Narayana.
Ah. Hey, इतने इधर बा इंद्रिश. Hello, Indrish. ಏನೋ ಸ್ವಾಮಿ. Okay, okay.
ఏమైంది మరి
Okay లే. చాలే.
ఎక్కడికి వెళ్ళాం తెలుగుతున్నానా
ఆ ఆ ఆ. లే అతను హిందీ. Okay, okay. See, this IP packet will tell you. See, this is the version 4. This is see 0100. This is the binary value. It is converted into decimal. This it will tell you this is the version 4. This is the header length. This is the 20 bytes is the header length. This is the differentiated value field is there, right? This is called type of service. What type of service it is? We need to transmit the data into the immediately, or it will tell you actually the four things. What are the four things is delay, throughput, reliability, and cost. Minimizing the delay, maximizing the throughput, and we have a less cost. So that kind of quality of service it is telling us. Okay, this version will tell you this is IPv4, IPv6. This is the total size of that. This type of service will tell you what kind of service this IP packet is providing. I mean, it's need a quick transmission or delay also possible, and and throughput. It needs to transmit a huge data or not. These details it will tell you. DTTH, delay, throughput, reliability, and cost. Okay, less delay must be the less, and throughput must be the high throughput, and reliability must be the high reliability, and cost will be the low cost. It is supporting these services or not. These details will tell you. Okay, here you can analyze that. That is, here we are calling it as a the internet. This is the IPv4, and this is the differentiated. This is the type of service. This is the identification. This is the flags. These are the flags are three types. First flag is it is reserved, and next one is the don't fragment D, and it is the M more fragment C. There are three flags are there. One, two, three. See here, one, two, three. Three flags and 13 bytes, 13 bits is for fragmentation offset. These three flags, first flag is for reserve. Next flag is the don't fragment. Don't fragment if you say D equal to 1, so don't fragment this any packet. Don't fragment this packet, it is telling that. If D equal to 0, fragment is necessary. Okay, that it is saying. See here you can see that the packet generation, how the packet is generated. IP header length is the 5. 5 is the 20 bytes. Uh, See, hello, English. Hello. It is multiplying with the value with 5. See, for example, this IP header length is 5. 5 into 4 into 20 bytes. It is multiplying with 32. Okay, this IP header length value it is multiplying with 32. This value, for example, 5 into 32 by 8, so 20 bytes. So why they are multiplying with 5, to save the uh, number of bits. For example, if they reserve more bits for IP header length, this field is a won't change every time. So it is a waste of resources. To save that resources, we are write a program that the value will be multiplied with 32 by 8. Means it is multiplied with the bytes into 4. 32 by 8 equal to 4. 5 into 4, 20 bytes. That's why to save the resources, they made a program that whatever the value is present in IHL, that value is multiplied into 32 by 8. See, for example, here, see, that is a where it is C. Header length. Header length is value is 0101. 0101 means 5 value. 2 power 0, 2 power 1 is a 1, 2 power 0 is a 0, 2 power 2 is a 4, 4 plus 1 is a 5. This 5 into we are multiplying, this is the value. See in brackets it is there, right? This is the value. This value is multiplied with 32 by 8. Total is the 20 bytes. So this value anywhere in TCP also, the header length is multiplied with 32 and we are dividing with the 5. That you will get the total length, IP header length. These flags are three flags. The first flag is the reserved flag. Reserved flag always the value will be the 0. And next flag is the don't fragment. This flag will tell you whether we need to fragment. I mean we need to divide this IP packet or not. When you are going to divide it, if physical layer is not supporting the packet size, whatever the packet size you have to divide that packet based on the physical layer. So it will tell you it need to fragment or not. If d equal to 1, don't fragment this packet. If for example if the fragmented d equal to 0 fragment, and it is this m will tell you m equal to 0 more fragments, m equal to 1 this is the last fragment. Okay, that it will tell you. See, for example, if you divided 4 packets, here you can see that here. This is the IHL is a 5 mean header length, and this is the total length, and this is the ID, and it is a flag. Flag will tell you 000. This 0 is a reserved flag. This 0 is a don't fragment. This is the m equal to 0. M equal to 0 means this is the last fragment. So we are not dividing the data. Fragmentation offset. We are not dividing. There is no offset. Offset will tell you where the last fragment in ending packet, and it is where it is starting. That is the fragment of offset will tell you. This protocol 6 it will tell you what is the protocol it is carrying. The 6 is TCP, the upper layer protocol. The top layer protocol, whether it is carrying a TCP data or IP data, see here it will tell you this protocol. This is the 17. 17 means it is carrying UDP. This protocol is 17. For example, this protocol number, this top layer, what kind of data it is carrying? Here are also 17. Uh, See what kind of this value will tell you. Every protocol having one value. The 6 will tell you it is carrying TCP data. Okay, and we have a what is the this is the time to live. This time to live will tell you. For example, from source to destination, there are 10 routers are there. Every router will decrease the value and transmit it. For example, there are different routes are there. One router. These are all the routers. Every router passing to this IP packet passing to here, this TTL value will decrement. Every router will decrement one of the TTL value and transmit here. Okay, what is the advantage of TTL is to remove the unwanted packets from the network. If the same packet is transmitting, I mean some unknown destination if transmitting, if you are no TTL value, the link is filled with the unconjuncted data. So to save that, we have a TTL time to live value. This value, the maximum is 0 to 8 bits to power 7 to power 8. It is having 128. The maximum value. See here, you can see that what is the TTL value. Time to live 140. So this value after crossing the another router, this value is decremented by 1. That is the advantage of TTL. Hello? Hello? This value is decremented. This protocol will tell you what is the top layer protocol it is carrying. Whether it is carrying a TCP data or UDP data. The transport layers are only two, and it is carrying SCTP. What is the transport protocol it is carrying? It will tell you this protocol. This header checksum for if any error occurs, the checksum by using this checksum, it is the IP header is corrupted or not. It will tell you source IP address and destination IP address. If the packet is generating, where it is generating, and destination IP address will tell you where it is going. This options part is options. Up to here, these 20 bytes are fixed header. This options part is the option. This padding is to match the 20 bytes header, means byte alignment purpose. That's why we are using this padding. See here, this IP packet need to be fragmented with maximum data size of 256. So why they are dividing 256 is they are using the PPP, point to point protocol. So they are dividing the packet. See, so how they are dividing the packet? This total packet size is 472. They are dividing 276, then remaining 216 they are dividing. The fragmentation offset, it is, it is starting with 0. Next fragmentation offset 256, because up to 256 it is transmitted. Then it is starting from again 256 to again 451. Up to 255 it is transmitted data. Okay, this IHL is the IP header length 5 bytes, means 20 bytes is the header length. Total length of the packet, how much size it is? 276. 20 bytes is the header and 255 bytes is the data. Total, see here, up to 0 to 255 is the data. 255 plus 20, 276. 0 to 255 means 256. 256 plus 20, 276. This is the ID. See, this ID will tell you, it is a fragmentation, ID. It is, and it is a flags. Flag 0, it is a reserved, and D is equal to 0 means fragment if necessary. M equal to 1, more fragments will follow. M equal to 0, this is the last fragment. This is a fragmentation offset 0 from 0. You see, for example, if you are cutting the 1 to 10, so how you are cutting? 0 to 3 one part, and 4 to 6 one part, 6 to 9 one part, last one is the one part. This fragmentation part will tell you which part you are cutting, from where to where you are cutting. This protocol 6 will tell you what is the top layer protocol. No, it is carrying. It is 6 will tell you it is a TCP. Like 17 it will tell you it is a UDP data. The data, this is the original data, application layer data. The same packet we are dividing into 128 bytes. How they are dividing? See, the total size is the 148. Size is only 0 to 127, 128 plus 20 bytes is the header. Total is 148. This is the ID, and flags 001. This 0 is for reserved. This 0 is for don't fragment. Equal to don't fragment equal to 0 means fragment if necessary, and the M equal to M, more fragments. More fragments equal to 1 means more fragments will follow. See, up to here, this more fragment equal to 0 means this is the last fragment. Like that, it is dividing the data. Okay, that is the IP layer. See, this is the version, 4 bytes of version. 4 bits are there. It will tell you it is IPv4 or IPv6. This is the IP header length IHL. It is having 4 bytes, so it is multiple with the 32, and divided by 8 to byte element. This type of service, it will tell you normal delay or no throughput. It is a maximum throughput and reliability. Low delay. What is the IP packet characteristics? It will tell you. This is the type of service. See, this protocol will tell you what is the protocol it is carrying. 1 for ICMP, 6 for TCP, and 17 for UDP, and 132 for SCTP. What is the type of service? What is the protocol? What is protocol? Top layer protocol it is carrying. It will tell you. And this time to leave is why we are using time to leave is to remove the unwanted packets from the network. This value is 8 bytes. The maximum value is the 256. This value is said to be high value, and every router crossing this packet, it will decrease the TTL value by 1. For example, if we set the TTL value as a 120, so 5 routers it is crossing. Then after 5 routers, this value will be 115, because it's every router by crossing it is decrease the TTL value by 1. The fragmentation offset is 13 bits. From which part to which part it is fragmented, then which part is starting. That will tell you fragmentation offset. This is the header checksum is a 16 bits. The checksum is header only, not the checksum is source and destination. See, the checksum will tell you whether the IP packet is corrupted or not. That is the source IP address. This is 32-bit destination IP address. Source IP address, whether the IP packet is generating, it will add is as a source, and destination IP address is the destination. And this is the for different example. For example, here version 4 IP header value, and total length 21 bytes. Here data is not there, only header is there. Only 1 bytes of data, and 20 bytes is the header. Only 1 byte in the data. That case, here 20 bytes is the header, 450 bytes as the data. Yeah, 472. 20 bytes are header, remaining bytes are data. It is carrying protocol 6 means it is a carrying TCP. Here time to value is 123. See, by crossing next thing, it will decrease the time to value. See, time to value is 119 only. These are the different example. Hello?
How you are deciding this is this much is hello?
Yeah, yeah. What is the
How
header?
you are deciding that 20 byte is data and remaining one is 20 byte is header and remaining data?
Yeah, this IHL value is there, right? IP header length. This will tell you what is the
Okay, okay,
header length of the. For example, this value is a 5. Total header size is the 20 bytes. This we are multiplying
okay.
this value into 32 by 8 to, for example, bytes. 5 into 30. It is you understand, right?
Yeah, 5 into 32 divided by 8.
8. I mean 5 into 4. 32 by 8 equal to 4,
5
right?
into
32 by
yeah. 5
32
into
by
4
8.
20.
Yeah. So 32 5
Okay,
into 4. For example, this value is instead of 5, it is a 6 value. So 6 into 4, 24 bytes. 20 bytes is the fixed
okay,
header. Remaining 4 bytes is the optional header.
okay,
IP header IP header is a minimum 20 bytes. It's not the any case. It's not the 20 bytes. IP header is changing. For example, if IP header is a fixed, we don't need IHL value. IP header length. See how their
okay,
programmers will know. They write a program that, hey man, first 4 bytes are version. If you read the first 4 bytes as a 4 value, it is IPv4. Read it as IPv4. Second, it will read the IHL
okay.
value. IHL is a 5 means 20 bytes. Hey man, up to read 20 bytes is the header. Remaining forward into upper layer. I don't care about the remaining data. I need to read only 20 bytes. They write a programmers write a program like that. Then only it can read that. This is a protocol, right? So the programmers will write a, while these protocols are designed by the professionals, right? After designing, they will give to
Yeah,
the programmers. Programmers will write the program. Then it will read the type of service. What kind of services this IP packet is providing? Is providing it's need to we need to transmit in immediately, or if delay also no problem. If the packet is transmitted immediately, the packet will choose the best path. I mean, less routers it need to transmit and reach the destination immediately. Emergency, this packet need to transmit in emergency or not. That is called high cost.
yes,
Low cost means if it is a delay also it can accepting. That is what kind of service it is providing. This total length will tell you total header plus data. What is the total length? Here you can see
okay,
148. 20 bytes is the header because IHL equal to 5. Remaining is the data.
okay.
Okay, then identification, this packet identification it is. See, you are dividing the this packet into 4 types. So receiver, how can I identify which packet, which part I got? See, you are divided the apple into four parts, man. Again, same apple you are dividing into 4 parts. Receiver will confusion. Hey man, which part apple it is? Because all apples are same, isn't it? If you divide
Yeah,
the apple into 4 chops and send it to the destination, the receiver will confusion. How can I arrange this packet? So likewise, to avoid the confusion, we have identification. If you divide the packet into 4 types, also identification is the same. So the receiver will by using that identification, it can arrange the packets. See, you can observe here there is no sequence number here. See, if you are dividing one packet into 4 packets, you definitely need a sequence number to arrange the packet into some particular manner.
yeah,
Yeah, but here there is no sequence number. How can you arrange in receiver side? See, one apple is there, man. I cutted the four pieces. I take some cutter and cutted the packet. I mean apple into 4 pieces and given to somebody to arrange it properly. How can he arrange? You don't know what is the starting and what is the ending. For example,
yes,
one amoeba is there or one fish is there. You don't know where is starting and where is ending, right? Here fragmentation will tell you what is the packet identification. It will identify the packet. What is the apple number it is. But the fragmentation offset is there, right? It will tell you. See, for example, you are cutting the human body. You are cutting first head you are cutting, then up to stomach you are cutting, then legs you are cutting. This fragmentation offset will tell you where it is, up to where it is cutted the packet.
Okay.
See here, this packet is there, right? The total size is the 256 bytes. The packet size is, total
Yeah.
size is 472 bytes, right? Here, this is the 456 total data, 20 bytes is the header. So this dividing into two types. It is starting from data offset. It is starting from 0 to total size is how much? 255 bytes. This is the data. Then fragmentation offset is
Okay.
starting from 256. At 0 to 255 it is transmitted. Next, from where it is transmitting? 256. So the receiver first
Okay.
received this packet. For example, the receiver received second packet instead of first packet. So the receiver will wait. Hey man, I receiving from 256. From where is 0 to 255? I need 0 offset. Okay,
Okay.
you are understanding, right? See, for example,
Yeah. Yeah.
in third cases, we are dividing the packet into four pieces. One piece, second piece, third piece, and fourth piece. The first fragmentation offset is 0. We are transmitting up to 0 to
Yes.
127. Next offset is starting from 128. 128 to 255. Next offset is starting from 256. Why? Because up to 255 we already transmitted in previous packet. See, for example, receiver
Yeah.
receive, how receiver will receive, man. First, for example, receiver receive this packet first. Receiver. So it will read that, hey man, this is the packet number identification, packet identification it is. Triple one is the number. Okay, fine. I am receiving from 358, 384. Hey man, I am receiving from 384 to 451. I am receiving. Okay. Where is the previous data? Then he received the second fragment instead of 1 and 3. He received the second. Hey man, this is the identification. This is the okay packet number is matching. But I am receiving from 128 to 255. Where is the first one and third one? Okay. So by using
Okay.
fragmentation offset, it will arrange the packet into some particular order, the receiver, and it will generate a packet, original packet. Original packet size is 472. Okay, are you understanding, right? By using
Yeah. Yeah.
by
Understand.
using the identification and fragmentation offset, it will arrange the packet. It will arrange the packet and it will generate the original packet and transmit from one end to the another end. Why it is dividing the packet is based on the physical layer characteristics. Physical layer is not supporting this much big data. The big data it is transmitting 451 is the packet size, but my physical layer I am using a copper cable. Copper cable it is not supporting this data, this much big data. So the router will divide the data. Router will divide the data and send it to the destination, another router will combine this data by using fragmentation offset and identification. Okay, that is the use of the fragmentation. This header checksum we need to identify that whether the received packet is corrupted or not. Okay, if the packet is corrupted, it is discard the packet, it won't retransmit. If it is retransmit, it need acknowledgement, right? Acknowledgement like that. But here no is no acknowledgement like that. If the packet is corrupted or not, it will check. If we receive the packet is corrupted, it will discard that packet. Yeah, that is the source address is the 32 bit. It will tell you what is the source IP and this is the destination IP. You understand, right? This is the different class of IPs. 0 to 256 is the class A, 228 to 191 is the class B, 192 to 223 different class of IP addresses are there. Okay, this is a different class of IP addresses. See, we are using for unicast, multicast, and broadcast. So, what is the unicast? Unicast is one-to-one transmission. Multicast is one to n. If 10 persons are getting the same data, that is a one to n. Broadcast is one to all. Okay, what is the difference? You understand? Unicast, multicast, and broadcast. See, unicast is one person to another person. Multicast is one to n. N is the fixed one. I mean, 1 to 10 people or 1 to 5 people, 1 to subscribed persons. How many people are subscribed? That many people it is transmitting. And here one to all persons. Here there is no need for subscription. It is going to transmit broadcasting. that cases it will also support the broadcasting also. It is saying that the IP. Okay, you are you understanding? See, the data link layer will receive the,
Yes, yes.
yeah, the data link layer will receive the packet. See, while receiving the packet in data link layer in input queue, it will check the destination IP address. If the destination IP address from the then it is forward the IP layer. If it is the same mission, okay, it can able to transmit it. Then look up the next hop. Then it is going to transmit. See how it is going to transmit is, for example, your computer is there, man. Your computer is generated a one packet. Okay, it want to transmit that packet. If the already it is in a LAN cable, it is connected to the LAN cable. You want to transmit in nearby system. It is no need to communicate with the router. When you are going to router to transmit the different networks of IP packets, to transmit into different networks, we need a router. But within the same network, if you want to transmit from one system to the another system, already LAN cable are there. Okay, then it can transmit directly. The data link layer itself it can transmit. There is no need for IP layer. See, the input packets are will come here. Then in IP layer it will check the destination address. Destination address is present, then it will demultiplex. See, this IP header is there, right? IP header it will tell you what is the transport layer it is using, isn't it, right? IP header is having a protocol. This is the protocol, right? Protocol is a 6, means it is carrying the TCP data. So after completion of IP header, it will read the TCP header. You understand, na? See, for example,
Yeah.
this is the raw data in RIST. This is the raw data. Okay, this raw data first it will read the physical layer, then physical layer header. Then from up to here it will read the physical layer header. Okay, from here to here it will read the data link layer, source MAC address, destination MAC address, and it will identify that. Then it will read the IP header. Then IP header, one field is there that is called protocol. Protocol it is telling what is the protocol data it is carrying. For example, if it is 6, it is carrying TCP. So next time onwards, it is reading the TCP header, not UDP header. Why? This IP itself it is telling what is the upper layer it is carrying. For example, this value is a 17. It will read the UDP header. UDP is the only 8 bytes of header. Okay, but TCP having 20 bytes of header. For example, it is having 136. It will read the SCTP header. The receiver reading, how receiver is reading the packet and displaying, that is the main criteria. Main criteria we have to understand this. See, for example, these cases, how it happened. This is the version 4, IPv4. This is the 20 bytes header. This is the quality of service. This is the total length. Total length means both header plus data. This is the identification. So we are not dividing the data. So there is no identification. These flags will tell you. This is the, where this is the fragmentation offset. Offset also 0 because we are not divided the data. This time to leave value is a 64. This protocol is there, right? This protocol field, that value 132 means it is carrying SCTP data. So after completion of 20 bytes, it will going to read the SCTP header. Why not it is going to read the TCP header? Because it is carrying SCTP data. In header itself, it is saying that the protocol value is SCTP. Okay. Then we have a header checksum. This checksum is for to check that it is carrying a valid IP or not. This is the source IP, then destination IP. Then it is going to read the SCTP header. See, stream control transmission protocol. From here onwards, it is a SCTP header. Okay. For example, in another case, see, this case it is carrying UDP. Protocol is a UDP. After completion of 20 bytes, it is going to read the UDP header. This is the UDP header. See, the receiver will read the source port, destination port, total length, and checksum. This is the UDP header. You understand, na? Hello,
Yes,
Indri.
yes.
Yeah, if you are not understand, let me know. The receiver, how receiver is going to read, that is the main criteria. See, then if the destination is the same, then it will, based on the port number, based on the protocol, it will transmit the TCP, or it is transmit the UDP. When it is transmitting, the protocol number is 17, it is going to transmit the UDP. If protocol number is a 6, it is going to transmit the TCP based on the protocol numbers. If you are not understanding IP protocol numbers, see, these are the protocol numbers who given by IANA. See, these are all the numbers. These are all the numbers, protocol numbers. Then if they see, then it is maintaining the routing tables. In router, it is maintaining the routing tables. Routing tables having two types: static routing and dynamic routing. By using some routing mechanism, you heard about RIP, BJP, OSPF. These are the dynamic routing configurations. They made a in router, they made a configuration that where to route that packet.
Yeah.
They are maintaining a routing table. If IP
Yes. Yes.
routing enable, it will check that in routing table. Static routing means you have to manually enter the routes. You have to, for example, one router is connected to four different routers. You have to give the address manually. All different routes it is connecting. Dynamic routing, you don't need to give the IP address manually. So it will configure then himself. The different routing protocols are, the RIP, BJP, border gateway, and OSPF, open shortest path first. There are different routing protocols are there. By using that routing protocols, it will transmit from one router to the another router. Okay. See how IP header is read the data. First, it validate the IP header. See, it will first validate the IP header is valid or not. Then process the IP header. Okay. If it is passing the destination IP address, it needs to find out the destination IP address. See, I will tell you one thing to you. For example, I buy a new laptop. Okay, I buy a new system, or it is everything is new. This is my system. See, my system is connected to the Wi-Fi. This is the Wi-Fi router. It is connecting. This Wi-Fi router having one IP address, and it is connected to the Wi-Fi router. This Wi-Fi also one of the router. So I want to connect. I type in my system. I type it www.google.com. Okay, okay. Just I open that new
Okay.
window. I just type it www.google.com. See, this Google server is present in somewhere in New York. So how it is going to that way, that place, and it is getting the data. How it is going is, first it will go to router. This router will check the destination IP. This Google having some IP address, right? This Google server having some IP address. To check the Google IP, it can route the packet or not. It don't know the destination IP. It will transmit the data to the default router. These default routers are useful when you don't know the destination IP. It can transmit the data to the default router. This is the default router. So in this default router, it will check the entries. It is maintaining the routing table, right? This table, it will check the destination IP address is present in his entry or not. So if destination IP is not present in this table, then it will transmit again into the default router. Okay, where to transmit? If you don't know the way to transmit, then it will. If this router will know where to transmit this packet, it can transmit into the router. Okay, that cases from one router to another router, it can transmit. Then it can reach the Google server. This Google server is present from here, for example. You understand, na? See, one router don't know
Yeah.
where to transmit the packet. It will transmit to the default router. The default router will take responsibility. Uh, where to transmit? I mean, which router is responsible to reach that particular server. For example, one router is this is the path for to reach the Google. For example, there are different paths to reach the Facebook. They don't need to transmit the same IP packet to the same destination, same router. They may follow the different path. They are maintaining routing tables like that. Based on that, they are transmitting. Okay, that is a
Okay.
advantage.
How do they come to know?
Yeah, that is a configuration.
How?
Yeah, I too don't know where
Okay.
how they know, but based on that configuration, see, for example, one router is connected to multiple devices or multiple routers, right? Neighboring routers. The routers
Yeah.
they will exchange their information. For example, in RIP case, routing information protocol, there is a hello timer is there. Every 30 milliseconds, they will say hello. Hey man, I am connecting this router. I'm connecting from this to this. This is the my table, and I'm containing these entries, like that. Like that, BJP also
Okay.
some they are exchanging information by using the routing protocols. So like that, they're maintaining routing tables, so it is transmitting the data.
Okay.
That cases it is that is going to be useful. This is the basic architecture. How receiver will understanding. See, receiver received these are all zeros, man. From the original data is this much only. See, this is all up to here. This is a header only. Every layer will remove the header and process it. That is the basic importance. Then it is decrement. Every router will need to decrement the TTL value. You understand what is the advantage of TTL?
Yeah.
Yeah, what is the advantage?
It is used for the security purpose, na?
No
For the
security,
reliability.
no reliability. See, this TTL value, 8 bytes of value, right? The 8 bytes means what is the maximum value? 2 power 8, 256, isn't it? The maximum value
Yeah.
is 256. See, why they are using is the source is generated a one corrupted IP, man. If there is no TTL value, the packet is still there in the network only, right? It is connected in the total wires, total Ethernet cables or something. The packet is corrupted.
Yeah.
If it is go to the destination, receiver receiver will say that, hey man, this is not my IP. It won't read that IP. First, it will check the receiver receive the packet. What it will check? Destination IP is matching his IP address or not, isn't it? See,
Yes.
source is generated packet. It is containing source IP and destination IP. If it is reached the destination, what it will read? Destination IP is his IP or not, right? If destination IP is not his
Yes.
IP, it won't read that IP. For example, source is generated some corrupted IPs, corrupted packets. It is not delivered to the any destination. So the packets are rounding entirely into the network only, right? How to remove that packets from the network or from the cables? How they remove is using TTL value. So every router passing to that IP packets, it will decrease the TTL value. For example, this TTL value we set it as 100, man. Within the 100 routes it must reach the destination. Okay, if the packet is not reached by crossing 100 TTL value, the packet will be decreased, packet will be discarded.
Okay.
See, for example, this is the TTL value, time to leave value 128 na. After another router, this TTL value decremented by 127. Another router, this is 126. Mean within the 128 routes it is reached to the destination. 128 routers, I mean nodes, you can treat it as a nodes. If it is not reaching the
Oh,
destination, this packet will be discarded. The
okay.
advantage.
Now understand and the importance of this TTL. For example, if we create a network,
Yeah,
in that network, if we create a route, okay,
yeah,
this is our BSC and this is our MSC and this is the route.
yeah,
And we decide that, okay, this much TTL is required to reach our packet from BSC to MSC.
yeah, yeah,
So if our node is down, for example, in between the path, there's some node is down,
yes,
then this TTL will discard that packet to reach to that MSC end. So we can identify that some missing is there in between the path.
yeah, yeah. That case it is useful. Means to remove the unwanted packets from the network. If if there is no
Yeah, yeah,
TTL value,
also.
there are a lot of unwanted packets in the network. Useless packets.
Yeah, yeah.
Lot of useless packets. To
And
remove.
also know the path delays also. If
Yeah,
there is a path delays,
yeah, yeah.
then the city also increase.
Yeah, like that. See, for example, I will tell you one thing. See, for example, uh, how it is. See, one router is there, na. This is the one router, man. It is having some IP address. It want to transmit into this router. Okay, okay.
Okay.
He know the IP address, but he don't know the MAC address. For example, this case, how he know the MAC address?
Yeah. By sending the ARP.
Yeah, by using the ARP, it will send by putting the TTL value equal to 0, 1. It will send the
Okay.
TTL value by 1. By reaching that packet, for example, this packet is reached by this router, this TTL value decreases to 0, right?
Yeah.
Every router will need to decrease the TTL value. We are sending TTL value equal to 1 by putting the TTL value 1, but we don't, and we want this MAC address, and we send it. So this, by reaching this destination, this TTL value equal to 0, and it will reply that ARP reply case. So we can remove the unwanted packets.
Okay.
Okay, that, for example, let's start one thing. This file. We'll start one here. It is coming or not? It is coming. No packets captured. Why? Oh, it is receiving the packets, right? Let's see. Okay, you understand today class, na? IP layer.
Yeah, yeah, I understand.
Yeah,
Yeah, yeah.
okay. Next, we go to discuss. We quickly complete tomorrow TCP and UDP.
Okay.
Yeah, you understand IP layer, right? Why it is used? Why every by receiving router, first it will check the IP header is correct or not. How it will check IP header is correct? It need to check the CRC header checksum is there, right? The practice that
Okay.
IP header, what are the fields are there? Every protocol, what is the main important thing is you need to understand the header. If you understand the header, you can understand the protocol. Every header, every field in the header having some functionality. See, in IP header also, every field having some functionality, right? Isn't it?
Yes.
This coming to
Yeah.
this version and IP header length and type of service and total length, this identification and flags and fragmentation offset, every field having some unique functionalities. If you understand these all functionalities, you can understand the IP, isn't it?
Yeah.
Yeah,
Yeah.
practice the header, and this is how it is receiving the packet. What it will check first, it will check the IP header whether it is a valid IP header or not by receiving checksum, by reading the checksum. Then process the IP header. It will check the destination IP address. See, parsing the destination IP address. If it is belongs to his destination only, it will read that packet. Otherwise, it won't read that packet. Then it will check the routing. It is having a table, right? I mean, routing tables. Then it will check the table, look up the table, how where to route that packet. Then it will decrement the TTL. Then it will perform the fragmentation if necessary. See, here it is if necessary means
Yeah.
it will check the physical layer. The fragmentation is necessary or not. Then it will calculate the checksum. Okay. then it transmit to the next node. This next hop may be another router or another computer only. For example, this is the last router, it will transmit to the computer. Send ICMP packet if necessary. Okay, you understand, right? See, one more thing,
Yes.
I will ask you one simple question. See, we are calculating checksum, right? Every router we are
Yeah.
calculating checksum. This is the receiving IP packet. Router, what is the functionalities it will do? Why we need to calculate checksum every node? Every
Uh,
router, why we need to calculate checksum? Anyway, we are calculating checksum at the
Checks.
source side. Destination will calculate the checksum. Packet. See, this checksum is what? Why this packet is corrupted or not?
Bhaiya.
Yeah. Hello.
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 Hello, can you hear me?
Yeah, yeah. Why we are calculating checksum at every router?
To verify that, to check whether the our packet is corrupted or not. If it is corrupted, then our checksum will be different.
See, I will show you IP packet. Tell me whether IP packet is changing or not. Okay. See, this is the 20 bytes IP packet, right? It is having 20 bytes IP packet.
Yeah.
It is having 20 bytes IP packet. This version will won't change from source to destination, isn't it? If you one packet is
Yes.
generated, the IP packet won't change from source to destination. Version will won't change. Okay. So what are the field will change? What are the fields are changing? Version will won't change.
This one.
IP header length won't change. Okay.
Yeah.
Type of service. If you at generating the packet itself, you will tell you what kind of service the packet is, whether it is emergency packet or what kind of. The total length is changing. See here, you can see that from here. What are the fields are changing? Total length is changing.
Yeah. Total length will change.
Yeah. What others are changing?
Total length is changing. Time to live also changing.
Uh, so these two values are changing, right?
Yeah.
Time to live and TTL. TTL will every router need to decrement the TTL, isn't it?
Yes.
So these two values are changing. That's why we need to calculate the checksum. If header is changing, we need to calculate the checksum. So how you know the received packet is corrupted or not? By receiving the header only, right? Isn't it? If you receive
Yes.
a bad header, you can tell that the IP packet is corrupted. So why every router need to check the checksum is IP header is changing from one router to the another router. What is that changing is TTL value is changing. Time to live value.
Yeah.
So every router is need to calculate checksum. But it is a what is the disadvantage? It will delay the transmission of packet, right? See, there are 100 routers are there. Every router need to check a checksum and they need to validate that IP address is correct or not, isn't it? It will introduce some
Yeah.
delay, right?
Yeah.
Yeah. But in IPv4 you need to check. But in IPv6 there is no need to check IP packet in every node. That is some disadvantage in IPv4. Every node it will need to check because this TTL value is changing. That is for today. IP you can just read the IP header. See, this is the IP header. I will transmit this file to you. Just read the IP header.
Okay.
You can get it from internet also, but I will transmit. And tomorrow we will trans TCP, and you have to tell me what are the TCP header in 5 minutes. What is the purpose of each TCP header?
Okay. Okay. Definitely.
Yeah, yeah. Okay, okay. Good night. Good night.
Good night.
Yeah, yeah. Good night, English.